when factoring quadratics, you have to look and see what kind of quadratic we have. Like in this case, we don't have a constant. There's not a constant involved here. We just have our x squared plus 6x, and then it's just set equal to 0. The set equal to 0 part is important because every quadratic has to be set equal to 0 in order to solve by factoring. Since this one's already set up the way we need it to be, the only thing we have to really do here is look for greatest common factors between our two terms. So for this one, it's really easy. The only thing that we can factor out is the variable x. So to do that, we have to divide each term by x. So here's what this looks like. We would have x getting factored out. We need to figure out what's going to go inside my parentheses when I factor out the x. So x squared divided by x gives me just x. So my first term in the parentheses is going to be x. Then 6x divided by x is just going to be 6. It's a positive 6, so I'm going to put plus 6. That's it. That's all there is. That's completely factored now. I do have to do the part where I have to solve, but the factoring part's finished. To solve, all I have to do is look at my factors. I've got x, and then my other factor is x plus 6. I have to set each one of those equal to 0 to get my answers. Now, in this one, it's really easy because it's just an x. So x equals 0, that's one of my answers. The other one, I have to set up x plus 6 equals 0. And you'll get the hang of this really quick because you'll have a lot of them that looks like x plus 6, x plus 5, whatever for a factor. And it makes it pretty quick to realize that your x value is going to be just the opposite of what you have in there. So for that to zero out, now I have to have a negative 6. I had x plus 6, so that means x would equal negative 6 to end up zeroing out. And the reason this works is, now for this example, it's not set up equal to 0 yet. I have a negative 3x on the right side. So I want to get everything onto one side. So I'm going to get everything to the left because that's where most of it is. So to do that, I got to cancel off the right, and I'm just going to add 3x to each side. And when I do that, I got to make sure that I only add it to, I can only combine like terms. So the 3x goes with the x. So I have negative x plus 3x makes it plus 2x. Bring down my minus 8. And I have equals 0. At this point, I have to start looking at factors of negative 8. Because what has to happen is I have to find numbers that when you multiply them, you get negative 8. But when you add them together, you get 2, which is our b value. Now, it gets to where it seems like it's a little bit tricky to begin with because you're looking for factors of negative 8. And that will add up to give you a positive 2. As you get the hang of these, it's going to be really easy. So I just need to find two numbers that multiply to give me 8. One of those numbers will have to be negative to make it a negative 8. But I want this to stay positive. So what happens is when I take factors of 8, and I'm going to go ahead and just put negative 8 there, I need to figure out what two numbers I can use. So it's going to be real simple to tell. It's going to end up being 4 and 2 is the numbers I'm using. But I got to make sure I understand which one's going to be positive. Well, in this case, 4 will be positive, and then negative 2 will be my negative number. Because if you multiply these two together, you get negative 8. But if you subtract 2 from 4, you get positive 2. Now, the reason I knew that the 4 was the positive number is because that's positive. And my bigger number over here has to be positive for the sum to stay positive. So if my b value is positive, then I have a negative c value. Then the number that's going to be positive out here, because I'm going to have one of each, is going to be the higher number. That's the only way that works. So I ended up having 4 and negative 2 for my factors. The way this breaks it down, x plus 4, because I have a positive 4, times x minus 2 would equal 0. Now, I could check that to double check that I've got this factored out correctly, to check your factors, you would just multiply back together. So I'd FOIL it back out. X times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And then I have 4 times negative 2, which is negative 8. When I combine like terms, I'm back to my original quadratic of x squared plus 2x equals, plus 2x minus 8 equals 0. So that works. Now I know that, okay, all the math I did, I factored it completely incorrectly. I can get rid of that. I don't need it anymore. And you don't need to do it anyway. It's just to double check. So I'm going to have x plus 4 equals 0, and I got to set up x minus 2 equals 0. And this is how I figured out the solving part of it. This is factored completely, but I've got to solve for my x now. So to do this, all I got to do is subtract 4 on each side. You're going to get to where you don't even have to do this math. You can just look at it and say, okay, well, the opposite of what I have in parentheses is what it's going to be. Because I had a positive 4 in parentheses, so I know that x would be negative 4 to make it 0. I had a negative 2 in parentheses, so I knew this x had to be a positive 2 to make it 0. 2 minus 2 is 0. So 0 times all this would make it 0. Negative 4 plus 4 is 0. So 0 times all this would make it 0. And that's how it works. That's all you have to do to solve it. First thing we want to do on this type of problem is we want to subtract the x. That way we get everything set equal to 0 on the right side there. And what's going to happen here, we've got x minus x. So our x's cancel out. We don't have any x's left on the left side. We just have x squared minus 9, which will equal 0. This is where the difference of square stuff comes in. We've got x squared minus 9, and 9's a perfect square. What that means, we can take the square root of 9. Square root of 9. And we know that is going to be positive 3 and negative 3. Right? Because remember, every time you take the square root, you get two answers. You get the positive version and the negative version of that. So square root of 9 is 3 or negative 3. So what we end up having in here, and it's because we have our x term is 1, or our a term is 1. So there is no coefficient for the x squared. It's just x squared. There's not like a 2x squared or a 3x squared. And then we just got subtract 9. It's just minus 9. If it had been plus, we couldn't do this. But since it's x squared minus a perfect square, and it's set up just like this, we can set up what is called difference of squares, and it's really easy to factor because it ends up just being x plus 3 times x minus 3. If we were going to check that, we would just, double distribute, FOIL it back out. X times x is x squared. X times negative 3 is negative 3x. So far I've done x times x was x squared. X times negative 3 is negative 3x. Now we're going to do 3 times x. It's going to be positive 3x. And finally, we'll do 3 times negative 3, which is negative 9. Your x terms will cancel each other out. You're left with x squared minus 9. That's because negative 3x plus 3x is 0. So those cancel each other out, and you just have x squared minus 9. And, really, that's all there is to it. When you do your factoring for difference of squares, which means it's going to be set up x squared minus, and then it's going to be a perfect square. It's going to be 9, 16, 25, 36, 49, any of those. It could have been 4. Any of those perfect squares. If it's sitting right here, it says x squared minus a perfect square, then that means we're going to do difference of squares. So we take the square root and we just do a positive version and a negative version. So what that ends up doing for us is the actual answers will just be 3 and negative 3 as well, which would be listed as, with braces, because it said to solve. Just to show you real quick what solving looks like, in case you forgot, you set each one equal to 0. X plus 3 equals 0. If you subtract 3 on each side, x would equal negative 3. What that means is if you plug this negative 3 in for this x, you say negative 3 plus 3 is 0. So 0 times this whole thing will make it 0, because if you multiply anything by 0, you get 0. I know I'm saying 0 a lot, but that's just what it is. And then you set up another one, x minus 3, because I got to do for this parenthesis now. These ones are pretty straightforward because our a value is 1. So I have x minus 3 equals 0. If I add 3 to each side, x equals positive 3. And I know after you get the hang of it, you're just going to look at this and say, okay, well, that says plus 3, so I know that's got to be a negative 3. This says minus 3, so I know that's got to be a positive 3 for my answers. And specifically is because, and I forgot to bring down minus equals 0, it's because that's the numbers that will make this whole thing equal 0, which is what you're looking for. That's why you set everything equal to 0, because then you can solve the quadratic by zeroing them out.